Okay, Year 10, scientific notation and significant figures. Now, we've done this before. We did it last year in Year 9, and you can do it manually, and you can use your calculator. So I'm going to show you two methods for doing this, but there are two things that we're dealing with here. We're dealing with scientific notation and significant figures. So let's go back and have a look at what the rules are for significant figures. So significant figures, if you come on, get the right one. Where's Year 10? Oh, it's Year 10 Elective 3. Significant figures are only used for measurement. So, because it tells you the degree of accuracy of the measure. So when we talk about significant figures, we wrote out some rules. Come on. Righto. Everything's a bit slow at the moment, and I'm sorry about that. So if I just come on. All right. Okay, so here we go. Revising index laws. You can see I've got some YouTube videos up there. So, significant figures. So you can read this. We've written the notes on the board. Introduce significant figures, wrote notes on the concepts. The number of significant figures tells you the degree of accuracy to which the measurement has been taken. It's only really ever used for measurement. Now, there are basically 5 rules for significant figures. And with significant figures, all you've got to worry really about is the zeros. Are the zeros significant? Because all other numbers are significant. It's only the zeros. So zeros between non-zeros are significant. So for example, if we're looking at, these are all scientific notation. If we're looking at a number here, so take this number here. How many significant figures there? Well, the 3, the 2, the 4 and the 8 are, so there's definitely 4. Is that 0 significant? Yes, because you've measured units, tens, hundreds, thousands, because you've got no thousands, but you've measured it. So this one has 1, 2, 3, 4, 5 significant figures. That's 0 significant. All those zeros are significant. Any 0 between a non-zero digits, they are significant. So there's the first one. So if you've got the 0 in the middle between two non-zero numbers, they're significant. So that's pretty easy. So you'll remember that. Let's go back. So all non-zeros are significant. Zeros between non-zeros. Zeros at the end of a number after a decimal point are significant. Why else would they be there unless the person writing the number wanted to indicate they'd measured to that degree? E.g., 2.10 has 3 significant figures. Otherwise, why would you put the 0 there? You don't need it for the place value. 7.800 has 4 significant figures. You don't put the 2 zeros at the end unless you think they're significant. So again, when we go back here, and we find a number with a 0 at the end, and I don't think we'll find any. No, I don't think we'll find any. Oh, it might be in, no. Now these have zeros at the end, but they're not after the decimal point. None of those have. So there are no ones, no questions where there's a 0, but you can understand what we mean. So if I were to write 7.80, I don't need that 0. It doesn't affect the place value. So the only reason it's there is because I've measured to that degree, and hence it is significant. So this number has 3 significant figures. All right, what's the next one? Zeros before a non-zero, but after the decimal point are not significant. Okay, they're only there to indicate place value. So 0.007 has only 1 significant figure. 0.0302 has 3. The 2 zeros before the 3 are not significant. They're there for place value. But the 0 in between is rule number 2, and it must be significant because I've counted or measured the nearest tenths, the nearest hundredths, because there are no hundredths, and the nearest thousandths. So if we go back here and we look at this, 0.08, one significant figure, 0.80, two significant figures. The 8 is significant, and so is the 0. So hopefully you're getting an understanding for that and you can deal with it. The last one, and this is where I think the book will have some different answers, is zeros at the end of a whole number may or may not be significant. You don't know whether or not they have been measured or rounded. For example, if I said there were 25,000 people at the football, did I measure to the nearest 25,000, to the nearest person, or did I round off? Were there 24,990? Were there 24,992? So where did I round off? Were there 24,500? And hence I rounded up to 25,000. There are definitely two significant figures, but you don't know whether or not I have rounded. So if we go back here and we're looking at these ones, okay, so these ones here, let's have a look at it. 4 significant figures. 1, 2, 3, 4, 6 significant figures. 1, 2, 3, 4, 5 significant figures. Let's find one that has zeros. No, they're all going to be significant. Here, this one has 3 significant figures, maybe 4, maybe 5. Okay, this one only has 4 significant figures. All those zeros before, not significant. This one, 3 significant figures. This one, all those numbers are significant. Same here, all those numbers, but the zeros before, not significant. Here, in this one, all those numbers, oops, this is a good one. All those numbers there, down to the 3, are definitely significant. The last 0, you don't know. We don't know whether or not they're significant. Okay, so let's do a couple of these questions now we've done that. And remember, scientific notation, and you should write your notes from here. Scientific notation, oh no, I haven't written, we did it last year, but scientific notation, to write in scientific notation. Okay, so I'm going to write a rule for this and you should be able to write your own rule. So, scientific notation, we're writing big and small numbers and we're writing them as a power of 10. So, scientific notation, you write a digit between 1 and 10. So from 1 to 10, 1 to 10, 1 to 9, 1 to 9. Right, 1 to 9, multiplied, because if you write 10, well then that's 2 numbers, multiplied by a power of 10. So, they're pretty easy. Here we go. So 2h. And I'm just going to have a look, get the answers up. And if I go here, year 10, 5.3. So 2h. Yeah, there we go. D, E, F, G. I've got it on my other computer, that's why I'm taking a bit of time. I'm sorry about that. Okay. So let's have a look at here. How many significant figures? 3. There are 3 significant figures. When you write them in scientific notation, every number is significant. How many significant figures? 4. How many significant figures? 3. How many significant figures? 2. These ones, however, I bet the back of the book says there are 6, but we don't know. I reckon there's only 3, possibly 4, 5 or 6, but they say 3 in the back of the book. Here, you don't know. There are definitely 2, but there could be anywhere from 2 to 8, but they say 2 in the back of the book. Here, how many significant figures? Well, all those zeros before are not significant. 1. Here, those 3 are significant. H, there are 3. Question 2, powers of 10, no worries. To convert these numbers here, now we're going to do this manually, but from after that, can you please use your calculator? So to convert to scientific notation, well, you have to move the decimal point. So what we're going to do is we're going to move the decimal point. The decimal point's currently here, and we're going to move it 1, 2, 3, 4 spots. So 3A, 4, 3, 1, 2, 3 equals 4.3. Remember, it must be a number between 1 and 9 times, what do we move it? 4 spots, 10 to the power of 4, because we moved it from the right to the left. Here, this one, how many spots are we going to move it? 1, 2, 3, 4, 5. So 712,000, so B, 715,000 equals 7.15 times 10 to the power, when we move it 5 spots. Now, you don't need all those other zeros. Oh, sorry, 7.12. What about a decimal? Okay, so let's have a look at G. And what do we got? 0.123, 4 zeros and a 3 equals. Well, how many? I've got to move this spot. 1, 2, 3, 4, 5. 3 times 10 to the power, but I've moved it the other way, so I just put a negative 5. Now, this one, and this is a question some student asked about, so I'm going to take my time with this. This is H. 0.0300401 equals. Now I've got to move the decimal point. 1, 2. All right. So my answer is 3. Now I have to put all these other numbers in because there's a 1 at the end. I've got to put all these other numbers in because I can't just leave them out. And I moved it 2 spots, so times 10 to the power of negative 2. You can't ignore those zeros. They're significant. Okay. Write these numbers as a basic numeral. Question 5. Well, question 4. To write them as a basic numeral, so 3.12 times 10 to the power of 3. So we're just putting it back. Oh, move that 1, 2, and 1 more, 3. Now, if there's nothing there, you put a 0. 3, 1, 2, 0. That's 4A. What about for, I don't know, let's do L. You should be able to do these. We did them last year. 1.237 times 10 to the 12. That means, oh, goodness me. That means, there you go, 1, 2, 3. I've got another 9 spots. So 1, 2, 3, 7. Another 9 spots, 9 zeros. 1, 2, 3, 4, 5, 6, 7, And you can't do that on your calculator because your calculator won't fit it. Your calculator has to write that in scientific notation. Let's have a look at 5. I'll do the first one, 5a. 4.5. 4.5 times 10 to the power of negative 3. There's a nice trick for this. I'm going to go 1 and then another 2 spots. So 0. Now I said another 2 spots, so 2 zeros, 4, 5. Now here's a really nifty thing. This number just tells you how many zeros as long as you put a 0 before the decimal point. If you remember that, you're sweet. You'll never get any of these wrong. So if I look at question number H and L. So if I look at 5H and what's 5H? 6.235 times 10 to the power of negative 6. That means I've got to have 6 zeros. 1, 2, 3, 4, 5, 6, and then I write the number. 6, 2, 3, 5. What was that? 5H. Beautiful. Let's go to the next one, L. So this is a really easy one to do. As long as you remember, you have to have the same number of zeros as decimal points. 8.75 times 10 to the power of negative 7. So 1, 2, 3, 4, 5, 6, 7, and then the number 875. So they're relatively easy. Now, when you write in scientific notation, every number is significant. So when you go 6A, and this is where we're going to use a calculator, I need to write that as a number, and I need to only write 3 significant figures. So it's 6, 2, 4, 1. You can try and convert the significant figures and then write scientific notation, but you're better off going, oh, that's 6.241 times 10 to the power of, how many spots did we move? 3. And now what do? I'm only allowed 3 numbers, so I've got to get rid of that 1. Now, if that was a 5 or more, I would round up, but it's not. 6.24, that number there is less than 5, so I do not round at all. I just leave it alone, times 10 to the power of 3. Let's find one that's going to round. So if I look at the next one, 572,644. So B, 572,644. Again, write it in scientific notation first. 5.72644. How many times did I move it? I moved it 1, 2, 3, 4, 5. Times 10 to the power of 5. And when I write it to 3 significant figures, I'm just looking at those numbers. I look at the number behind. Is it 5 or more? Yes, it is. I need to round. 5.73 times 10 to the power of 5. Now, when you do these on your calculator, it's so much easier. So here you go. What you do is you set your calculator to scientific notation. So you go Shift, Set, and 7. And it's going to ask you, how many significant figures do you want to go to? Well, we're going to 3, so we'll put in 3. Now every time we type a number in, it'll do it automatically. Watch this. 6, 2, 4, 1 equals exactly what we got. 5, 7, 2, 6, 4, 4. Exactly what we got. Use your calculator. Use your calculator for scientific notation, conversions, and significant figures. Hopefully that's been enough. You'll be able to have a go at the rest of them. So even these ones here. So if I look at these ones here, write in scientific notation the figures in brackets. So our calculator's already set. So watch this. So look at these, what are they? 8. So here we go. Let's do 8i. Point. How many zeros are there? 1, 2, 3, 4. 1, 2, 3, 4. 5, 0, 0, 3, 4. 5, 0, 0, 3, 4. And I'm just checking the answers. I know it's right. And question 8, L 5.00 times 10 to the power of -5. Your calculator does it. And if you leave your calculator in scientific notation, when you're doing these questions, all right, you just set your calculator to scientific notation and 3 significant figures. So here, look at the first one, 2.13 to the power of -7. So you go brackets, 2.13 to the power, what do we got? -7. No work required. That's the answer. How come I've got a different answer? Oh, because it's 2.31, 2.31. There we go. There's the right answer. Your calculator does it for you. All right, good luck with that. Remember, keep emailing me if you're having issues.